In this video, we're going to be looking at how to find arc length and the sector area of a circle. So when we say arc length, we're actually talking about the arc, right? For in other words, from point B, if we were to follow around the circumference of the circle, all the way to point C. So we were calling that like in this case, it'd be called a minor arc if you looked at the last video. And now what we're going to do is we're going to calculate the length of it. Now, some of the information that you've already been given in the previous videos is you know that there is a vertex, which is the point where the two radius connect and create an angle. That angle is called the central angle. And so I'm going to go ahead and just label a few more things on here. I'm going to turn this around and we're going to call this right here the arc length. So we'll be finding that today in this video. The other thing that we want to find is what we call the sector area. So when we talk about sector area, this whole area inside of here, imagine this is a slice of pizza. That whole slice would be called the sector area. We want to know how many little cubes can fit inside of this angle all the way up into the circumference. So in other words, I'm going to get my highlighter and I'm just going to kind of highlight this whole inside. So how many little cubes can we fit inside of this section of the circle? So those are two things we're looking for. When we talk about arc length, we're going to use a formula, and I'm going to go ahead and say arc length is represented by the variable s. And then when we talked about sector area, we're just going to use an a for the variable that represents the area of the sector. In other words, a represents how many units can fit inside of here, while s represents the length from one point to the other on the arc. Now on these types of problems, they're going to give you the radius, because you'll need that value, and they're going to give you an angle, right? A central angle. Notice our central angle is 95 degrees, and our radius is 4 centimeters. So what we have to do is we're going to take that information, but we got to do a conversion before we can use the formula. So for instance, I'm first going to go ahead and find this arc length. The formula for arc length is going to be S is equal to theta times R. So I'm going to go ahead and change this to an S. That's just going to be the length, the arc length. But before we can do that, we have to find theta. Now theta is going to be a value that's written in radian, not degrees. And the way we get theta, which is basically the angle measured in radians, is we have to use this formula of pi over 180 times the central angle. So we're going to go ahead and do that real quick. I'm going to move this up a little bit. Notice we said earlier our central angle on this problem is 95 degrees. So I'm going to rewrite this up here. And I'm going to write pi over 180 times, so I'm going to put a parentheses, it means we're multiplying. And then I'm going to write the 95 degrees in here. And whatever that gives me is going to be theta, which we're going to be using in our formula. So I'm going to get my calculator so we can calculate that real quick. So I'm going to go ahead and use my fraction bar by hitting alpha y equals, enter. There's my fraction bar. I'm going to put pi in the numerator by hitting second, and then the caret key that gives me my pi symbol. Put 180 in the denominator, click to the right, and now I'm going to put a parenthesis, and I'm going to go ahead and type in 95. Close parenthesis. Hit enter, and notice it gives me 1.65806. So that is going to be what theta is equal to. So our value for this angle in radian is going to be 1.65806. We're going to use this number in our formulas over here. So now I'm going to go here and we're going to start substituting some values. Notice it's pretty easy to find the arc length once you have theta, because we're just doing theta times r, which is the radius. And if I go back to the problem up here, notice my radius was 4 centimeters. So I'm going to move it back up. So we're going to go ahead and I'm going to substitute into this formula. So in place of theta, I'm going to go ahead and put parentheses. I'm going to write this number, 1.65806. And then for the radius r, I'm going to put the value that we've seen up here, which was 4 centimeters. So I'm just going to put parentheses and put a 4 in there. And whatever that gives me is going to be what S is equal to. So in other words, S is equal to this value. And that's our arc length. So I'm going to go ahead and get my calculator and I'm going to type it in. So instead of me typing this whole number in again, I'm actually just going to click up to highlight it and hit enter, and it'll bring it down and put it in the parenthesis for you. Close parenthesis, put another one, and then put the radius value, which is 4, and then I'm going to hit enter. And it gives me 6.63224. So S is equal to 6.63224. And we are going to round this to the hundredths place because that's what it looks like a lot of y'all's work. Your teachers want you to round to the hundredths place. So that's the second number to the right of the decimal. That's the hundredths. So this 2, remember 4 or less, let it rest. 5 or more, raise the score. So since it's 4 or less, we're going to leave that 3 as a 3 and rewrite this number now. So my final answer is going to be 6.63 for the arc length. So I'm going to go ahead, use my highlighter real quick. That's my arc length. I'm going to come up here and I'm going to write that value right here. So this arc length right here is going to be 6.63 centimeters. Now what we want to do is we want to find the area inside of this sector. So we want the area. We want to know how many little boxes can fit inside of here. These are little cubes. So we already know what theta is, so it's going to be very easy to find how many cubes we can fit inside of here. And I say cubes, how many little squares. So I'm going to move this up, and we're going to use this formula, the sector area formula. So for that formula, we're going to do A is equal to 1/2 times theta times the radius squared. So we already know some of those numbers, so it's going to look very similar to what we're already doing. So we have A is equal to 1/2. But instead of theta, I'm going to put the number in for theta. So in this case, right, it's the same number we used up here for theta that we had calculated by doing pi over 180 times the 95 degrees, which was the value of the central angle. And it's 1.65806. So 1.65806. And then times the radius. And the radius on our shape was 4. The same value we used here for our radius. The only difference is now we're going to square it. And then we'll write our final answer and we'll round it to the hundredths place. So now we have our parenthesis, and then we have 1.65806 close parenthesis and parenthesis, and then we put our radius, which is 4, and then we square it. Hit enter, and notice we have 13.26448. So 13.26448. And now what we're going to do is round it to the hundredths place. So I'm going to underline the hundredths, circle the thousands, and that 4 tells us to let the 6 rest. 4 or less, let it rest. So our final answer for A is simply going to be 13.26. And that is how many little squares can fit inside of this area right here that's on the other side of the arc. And we call this the sector area. So right here, sector area is 13.26 centimeters squared. And that is how you find the arc length, and that is how you find the sector area.